Welcome, this is Professor Ridge. Today's lesson 8.1, the ellipse. And our first learning objective, write equations of ellipses in standard form. A conic section or conic is a shape resulting from intersecting a right circular cone with a plane. The angle at which the plane intersects the cone determines the shape of that cross section, right? So if you took this plane and let's see here. This is the way I like to think of it. If you can imagine the center, so if you look at this top cross section is a circle for the cone, and you drop the center line down. So if you reference how the plane cuts, it cuts in reference to that center line. If it cuts at an angle, you're going to get an ellipse. If it cuts where it's parallel to that center line, you will get a hyperbola. And if it cuts where it's parallel to the edge of the cone, you will get a parabola. Now, the one other conic section they didn't mention is if I took a plane and sliced it perpendicular to that center line, that conic section is going to give me a circle, this top piece here. Okay, so let me erase my sloppy drawing there. But that's also considered a conic section, a circle. But since we studied that before in other contexts, they didn't add it in the book here. But it is a proper conic section. So there's technically four. There's the ellipse, the hyperbola, and the parabola, the circle. And then if you want to get real technical, if you slice the plane right through here, actually I erased that. If I slice it right through the center, right through here, the only intersection point would be that, it would be a point. So a point is technically a conic section, but not what we call a proper conic section. How come that didn't erase? And then if you slice it where it just touches the edge of the cone, you would get a line. So again, technically, a point is a conic section, a line, and then those are called the degenerative cases. And then the four proper conic sections would be the ellipse, hyperbola, and parabola, and then the circle. Okay, so they didn't draw the circle here. Okay, so an ellipse is the set of all points x and y in a plane such that the sum of their distances from two fixed points is a constant. Okay, each fixed point is called a focus, and the plural is foci. We can draw an ellipse using a piece of cardboard, two thumbtacks, a pencil, and a string. So if you wanted to make one at home, or if you wanted to cut out a nice perfect oval, you just get a piece of string, whatever length you want. You tack both ends on to the cardboard or the wood board if you're doing it on wood, and then you can just put your pencil on the string like this and make it tight, and then just trace around, and as long as you keep the strings tight, it's going to form and it'll make a oval or an oval or an ellipse. Okay, so every ellipse has two axes of symmetry. The longer axis called the major axis, and the shorter axis called the minor axis. So each endpoint of the major axis is the vertex of the ellipse, and then the plural for vertex is vertices. Each endpoint of the minor axis is called a covertex of the ellipse. The center of an ellipse is a midpoint of both the major and minor axis. The axes are perpendicular at the center. The foci always lie on the major axis, and the sum of the distances from the foci to any point on the ellipse, the constant sum, is greater than the distance between the foci. Some people pronounce this foci, so you could say the hard C, soft C, whatever you want. I've heard it said all the different ways. Okay, so the key things to remember, so the center, right? This is the center of the whole ellipse. And then we have the minor axis. And then at the endpoints of those minor axes are the covertex. The major axis, again, the major is the bigger one. Minor axis is the smaller one. The end of the major axis, the endpoints, are the vertices, vertex singular, vertice plural, and then the foci, right? So these are the major terms that we need to learn. And this is how you build the foci is how you build the, what do you call it? The ellipse. So if you figure out that distance, that's going to be a constant, some constant number. It's going to be fixed. So basically, if you get that piece of string, cut it, and have it a certain size, that's going to dictate the exact shape of this ellipse. Okay, so it'll always be a constant. Okay, so with all that information, we can derive the equation of the ellipse centered at the origin. So to derive the equation of the ellipse centered at the origin, we begin with the foci negative C0 and C0, and the ellipse set of all points xy such that the sum of the distances from xy, so that's a point on the ellipse, to the foci is constant. So if you measure this distance d1 and measure this distance d2, that's going to be equal to some constant. And then we can use the distance formula and then derive it. So I encourage you to read in the text. I'm not going to go through it line by line. You can, it's hopefully pretty clear. You should look at it and try to understand each step. I'm not going to go through it, but then we just jump basically to the last line and we get something like this. It's going to end up being x squared over a squared plus y squared over b squared equals 1, where a squared minus b squared is equal to c squared. Okay, so here's the standard forms. Now there's two types of ellipses that we're going to concentrate on, where the major axis is on the x-axis. So that's what we call a horizontal major axis. And then the major axis is vertical. So this is a vertical major axis. And these are the two standard forms. They're basically the same, but you'll notice that this one's x squared over a squared plus y squared over b squared equals 1. And then the vertical major axis, you have the b squared under the x and the a squared under the y. And basically the way we do it is we just define a to be bigger than b, right? So wherever the bigger number is, that tells you what the vertical axis is. So if the bigger number is under the x, that's x is going to be the horizontal major axis. Or if it's centered at 0, 0, it'll be on the x-axis. And if the bigger number's under the y, that would be a vertical. Okay, so that's the only thing. The length of the major axis, so if you kind of look at the way this works, is if we take the square root of a squared would be a, and then that's the distance from the center to the vertex. So the length of the and then you have minus a over here, and they're symmetric. So if you have a going that way and minus a going that way, that's going to give you the length of 2a, because you're going a and to the left and a units to the right. So that would be 2a. And then the coordinates of vertices are plus or minus a comma 0, like we just talked about. And then the minor axis is going to be 2b. So if you take the square root of the b squared, that gets you b, and you go up b, down b, that the length of the minor axis will be 2b. And then the coordinates of the covertices be 0 plus or minus b. And then the foci is plus or minus c, and now where you get c is you're going to subtract these two numbers. So you subtract them and then take the square root of that difference, and then that'll give you the length of C. Okay, so if A was, say, 36 and B was 25, 36 minus 25 would be 11, and then the square root of that would be whatever it is, and then that's how you figure out where the foci are, or foci. And then similar, you do the same thing for the vertical major axis, but just make the appropriate changes. For the major axis, if it's vertical, you're going to go up A, down A for the vertices. And then for the co-vertices, you're going to go to the right B, left B. Okay, so you just make the appropriate changes. Okay, so let's try example 1 here. What's the standard form equation of ellipse that have vertices plus or minus 8, 0, and foci at plus or minus 5, 0? So, and I'm going to constantly switch between saying foci, foci, foci. I say them all the different ways. Okay, so determine whether the major axis lies on the x or y axis. So if we kind of just, I always just do a real super rough sketch. So plus or minus 8. Let me try that again. So we got 8, 0, negative 8, 0. So the major axis is going to be horizontal, and the foci is going to be at 5, plus or minus 5. Okay, so we know it's going to be the x-axis, so we know it's going to be x squared over a squared plus y squared over b squared equals 1. We're going to use this one. Now use the equation c squared equals a squared minus b squared along with the given coordinates for the vertices and foci to solve for b. So remember, this distance from the center to the foci, that's c. So that's 5. And the distance from the center to the vertex, that is a. So a is 8, c is 5. So now I'm going to use this equation that relates a, b, and c. So we get a squared minus b squared equals c squared. So let's see, a squared is 64. 5 squared is 25. And then I'm going to subtract 64. So b squared is, what's that, 39? Let's see, 39. And then negative 39, and then I divide both sides by negative, so those become positives. And then square root it. So b is square root of 39, plus or minus, but you throw out the minus one because, right, this is a distance, but when we go back, oh, actually I didn't have to do this because I just need to know what b squared is. So now I have my equation. X squared over a squared was 64 plus y squared over b squared is 39 equals 1. And then that's my answer. All right, of course now we can move the center with our transformations. So the center doesn't have to be at 0, 0. We can move it to HK. And pretty much everything stays the same. If you know, you can just think of this as the pretend origin, the center. And you're going to go plus a minus a for the vertices. So if it got moved to, if the center got moved to HK, then you're going to do plus or minus a to the h coordinate. Okay, that's kind of the way I think of it. And then for the b, you're going to do plus or minus b to the y coordinate. So it'll be hk plus b hk minus b. And then your foci, you're going to do the plus or minus c to the h coordinate for the foci. And pretty much everything's the same. Major axis still 2a, minor axis still 2b. You still have this equation that relates a, b, and c. So c squared equals a squared minus b squared. And then again, just do the appropriate changes for the vertical one. So the major axis is vertical, so you're going to add, subtract a to the y coordinate on the vertical one. And add, subtract b to the x coordinate. Okay? So you make the same changes. And then, of course, the foci, since this is a vertical. Oh, and this is another thing I should mention. The vertices and the foci are always on the major axis. So if the major axis is vertical, you're adding, subtracting to the y coordinate. If it's horizontal, you're adding, subtracting to the x coordinate from the center. So if the center's not 0, 0, it gets moved to hk, then you got to do h plus c, comma k, h minus c, comma k for the horizontal major axis, and the vertical major axis you do it to the y coordinate. So it's h, k plus c, and then h, comma, k minus c. Okay, let's look at example 2. What is the standard form of equation of ellipse that has vertices -2, -8, and -2, 2, and foci -2, -7, and -2, 1. So again, I just like to do a rough sketch, nothing perfect, but the idea is -2, -8. So let's see, -2, -8. So maybe -2, -8. I'm just doing a rough sketch. And then -2, 2. So that's going to give me my major axis, which is vertical. So that tells me I'm going to use this form. I'm going to use the x minus h squared over b squared plus y minus k squared over a squared equals 1. And then the foci, or foci, are -2, -7. So -2, -7. And then -2, -1. Actually, my drawing's a little bit off. Okay. So this is -2, 2, -2, 1. Okay, so the center is going to be the midpoint from here. So how do you find the midpoint between 2 points? Well, you add the coordinates and then divide by 2. So the center is going to be, let's see if they use that. This is the midpoint formula, right? They didn't show you that. So I'm going to do -2 plus -2 divided by 2. And then -8 plus 2 divided by 2. So that's going to get me -4 divided by 2, which is -2, right? So it's still on that vertical line. -6 divided by 2 would be -3. So the center's at -2, -3. Okay? So that will be my h and k. So now, my equation is going to be x minus a -2, so that's plus 2, over b squared, which we'll figure out in a minute. And then y minus a -3 would be plus 3 squared over a squared equals 1. So a squared, remember, a is the distance from the center to a vertex. So how far is it from -3 to -8? Well, that's going to be 5 units. So 5 squared is 25. Okay, so if a is 5, a squared is 25. C squared is the distance from the center to the foci, right? So that distance. So C is equals, so we're going from -3 to 1. So that'd be 3 plus 1 would be 4. This is why I draw a little sketch. It just kind of helps focus, what I'm looking for. And I don't have to necessarily bust out a formula. I can look, okay, well, that's 3 units plus one more. It's 4 units. So C is 4. So now I need to figure out B using this formula. C squared is A squared minus B squared. Well, this C is, I should say, center. Okay. Yeah, that was confusing me, but C and then C. C is going to be, C squared is A squared minus B squared. Well, C squared is 16. A squared is, what was A? 5. 5 squared is 25. So we're going to subtract 25, which gets us 9. Well, it gets us negative 9. And then B squared is, you divide both sides by negative 1. So B squared is 9. And then we're done. That's our solution there. Okay, on to the next learning objective. Graph ellipses centered at the origin. Graph an ellipse centered at the origin. So graph the ellipse given by the equation x squared over 9 plus y squared over 25 equals 1. Identify and label the center, vertices, covertices, and foci. Okay, so if you just wanted to graph this thing, it's super easy, right? So first you identify it's centered at 0, 0, right? Because it's x. Remember, it's x minus h, which is 0. So there's no plus or minus 3 or whatever. Same thing for the y. So its center is 0, 0. So we can plot 0, 0. Okay, so I'm not going to actually do it all this way. This makes it a little more complicated. So you just plot, and you don't even have to really worry about is it a vertical major axis or a horizontal major axis. Just go, here's what I do. I say, okay, here's x. Under the x, I take the square root of 9. Square root of 9 equals 3, and I'm going to do plus or minus 3 from the center in the x direction. Now, I'm not worried about if this is the major axis or the minor axis. So I go plus 3 minus 3. Dot, dot. Then I do the same thing for y. Square root of 25 is plus or minus, technically it's plus 3, but I'm going to do plus or minus that. Plus or minus 5 from the center it's under y in the y direction. Now I'm saying this because when we move away from we move the center away from 0, 0, right? You want to think x direction is x direction side to side, y direction's up, down. Okay, so we're going to go plus 5 minus 5 from the center, and those 4 dots make the vertices and the covertices. So of course the ones that are further away, that's the vertices. So 5 and negative 5 would be the vertices. So this would be 0, 5. This would be 0, negative 5. So those are the vertices. So this is vertex 1. I put a little subscript, and vertex 2. And then our covertices. Now, if I just want to graph it, I don't even have to do that. I just make my best attempt of an oval to connect those 4 outside points. I have an oval tool here. So basically, I just have to go to that corner, drag it out. Now, if you're doing it by hand, you just make your best attempt at making that oval. Oops. There we go. Okay, and that's it. But here we wanted to, it asked us to go ahead and label everything. So that's the vertex, here's the center, which is 0, 0. This is the co-vertex. So that's 3, 0. The other co-vertex, negative 3, 0. And then foci, so now we got to do a little math here. So remember, c squared is, you're just going to subtract. So 25 minus 9, which is 16. And then the square root of that is 4. And again, c would be just the positive one, but oops, square root of 16, which is plus or minus 4. So we go plus 4 minus 4. Technically c is 4, but so focus 1 is 4, 0. Focus 2 is negative, oops, I did that wrong. So that should be 0, negative 4. This should be 0, 4. Okay, and that's it. All right, so it's pretty simple. If you didn't have to label all this other stuff, it's really simple. I just go to the center, 0, 0. Under x, square root of 9 is 3. So from the center, plus 3 minus 3. Under the y is 25. Square root of 25 is 5. So from the center, go plus 5 minus 5. And then make your oval to connect those 4 outside dots. And you're done for graphing. All right, let's try let's try example 4. Graph an ellipse given by the equation 4x squared plus 25y squared equals 100. So your first steps, you're going to rewrite in the standard form. So remember, standard form has to be equal to 1. So we're going to divide everything by this number 100 and reduce it. And 100 divided by 100 will get us the 1. Oops. Get us 1. And then 4 goes in 100. You divide 4, that's 1. Divide by 4, that's 25. Divide by 25. So we get x squared over 25 plus y squared over 4. Now to graph it, okay, again, let's just do the easy way that I showed you. So we just have x squared, there's no plus or minus anything. Y squared, there's no plus or minus anything. So that's just going to be centered at 0, 0. Then under the x, right, square root of 25 is, we're going to do plus minus 5 from the center. So you go plus 5 in the x direction, minus 5. Under the y, square root of 4, again we do plus minus 2 in the y direction, so up 2, down 2. Then we make our oval, so I'm going to use my oval tool here. Just drag it out, make sure I hit all 4 of those spots. Oops, didn't quite do it. Okay, close enough. There we go, that's better. All right, so then that's it. And I'm done graphing. But they did want us to label all this stuff. Okay, so the center is 0, 0. Center. This would be the co-vertex. So that'd be 0, 2. This would be a co-vertex. 0, negative 2. This would be vertex 1, 0, oops, be 5, 0, vertex 2, negative 5, 0, and then the foci, we're going to do 25 minus 4, which is 21. And then the square root of that is, let's see here, 21 square root, 4.58. 4.58. 4.6. So right about there. Okay, so F1 is square root of 21, 0, and F2 is negative square root of 21, 0. Okay, our next learning objective, graph ellipse is not centered at the origin. Okay, so I'm going to do it the my simplified way. So first, I always start with the center, right? So the center is the HK. So remember, you got to switch these signs. So center is HK, so it'll be negative 2, positive 5. And I'm going to plot that. So negative 2, negative, or positive 5. Okay, I got to rearrange my axis here, so hang on. Okay, so let's see here. So negative 2, 5. Now, again, I'm not going to worry about what's the major axis and minor axis. I'm just going to look at, this is the x, so that's square root of 4 is 2. So I'm going to do plus or minus 2 in the x direction. So plus 2 from the center, minus 2. So here's my center. So that is negative 2, 5. And then in the y direction, I'm going to do square root of 9, which is 3. So I go plus 3. So 5 plus 3 would be 8. 5 minus 3 would be 2. In the y direction. That's my ellipse. I'm done. If I just, well, I got to draw the oval now. Connect those 4 outside points. So that's it as far as if I want to draw it. I'm done. But they asked us to label everything, so we will. So now we got to realize, okay, oops. Oh, darn. I don't know what happened. For some reason, this program does that when I use the mouse. See? Okay, let me try that again. There. Okay, so now I got to label everything. So now I got to realize, okay, the bigger number was under y, so this is a vertical major axis. So this is vertex 1. And then remember, if we were at negative 2, 5 and added 3, then we added it to the y coordinate. So that would be negative 2, 8. Or you can just look, right? This is negative 2, 8. And vertex 2 is negative 2, 2. And then the covertex is 0, 5. And the covertex 2 is, let's see, with negative 4, 5. And then remember, the foci is always on the major axis. So we got to figure out what c is. C squared is, you're just going to subtract the bigger one minus the smaller one. So c squared is 5, and then you square root it. So square root of 5 is like 2.3 or so. So right about here. So that would be our focus 1, which is, now we're adding it to the y coordinate. So it'll be negative 2, comma, 5 plus square root of 5. And then this one would be negative 2, 5 minus square root of 5. Okay, so that's all your points. Example 6, graphing an ellipse centered at HK by first writing it in standard form. So we got to rewrite this in standard form. So what you do is you have to put the x squared x term together. So I'm just going to rearrange this. and then put the y squared y term together. And then I'm going to subtract the 100 and put it on the other side. Now I want to complete the square, but what you have to do is you have to factor out the coefficient for the quadratic term. So 40 divided by 4 is 10. And then you're going to complete the square inside this parenthesis. So you add it, subtract it, instead of adding it to both sides. And then you do the same thing for the y term. You got to factor out the y squared coefficient. So 9 divided by 9 is 1 y squared. 36 divided by 9 would be 4 y squared. Now, I should point out too, if this was a number that doesn't divide by 9, it doesn't matter. You just write it as a fraction. So say it was like 25, you'd write 25 over 9. Okay, so if I had like 9y squared plus 25, when I factor out the 9 doesn't divide evenly in that, but it doesn't matter. You still got to factor it out. Okay, so that's an important thing to note. Okay, so back to our problem. So we have, so I like to do this to get my completing the square, just get in my head here. Okay, so I'm going to take half the middle term, 10 divided by 2 is 5, square it, and then that's what this, for the perfect square trinomial, this is equal to x minus 5 squared. Now you can't just add 25, so you got to balance the equation. So you have options where you add 25 to both sides, but since it's inside this parenthesis, I can't use that option. I got to add it, subtract it, and you can see this is equal to 0. So I'm not doing anything, I'm just rewriting it. And then I have this, the first three terms, this is the square, right, the x minus 5 squared, and then I'm multiplying that by the 4, right? And I got to distribute the 4 with this, so minus, I'm just going to write it like this. Normally I'd write minus 100. So you got to multiply by 4 times the 3 terms, which is this first expression, and then 4 times the 25. Do the same thing for y. Half the middle term is 2. 2 squared is 4, so I add it, subtract it in the parentheses. Now I distribute this 9 times the first 3 terms. Oh wait, what did I mess up? This shouldn't have been a square. That should have just been y. Okay, so half the middle term is 2, and then 2 squared is 4. So these 3 terms make a perfect square trinomial, y plus 2 squared. And then I multiply by the 9, so minus 9 times 4. And again, normally I would just write 36 here. Okay, so now I have 4x minus 5 minus 100. 9y plus 2 squared minus 36 equals minus 100. So I want to add 100 to both sides. I want to add the 36 to both sides. So I get 4x minus 5, I forgot my square, plus 9y plus 2 squared equals 36. Now I want to get in standard form, so one more step here. I want this to be 1, so I divide by 36. And then reduce. So divide, that'll be 1. Divide by 9, that'll be 4. So my standard form is 9 minus 5 squared over 9 plus y plus 2 squared over 4 equals 1. All right, now I want to graph this. Okay, so our center is going to be HK. So remember, you switch the sign. So it'll be positive 5. K is negative 2. So we're going to go plot that. 5, negative 2. Under the X, right, we're going to square root that number. So that'd be, we're going to do plus minus 3 in the X direction. So plus 3 minus 3 from the center in the X direction. Y direction, right, under the Y. Square root of 4 is 2. So we're going to do plus or minus 2. So go up 2 from the center in the Y direction. Then we're going to make our oval, which is an ellipse, the common name for ellipse. Okay. There we go. And I think they wanted us to label everything again. So let's see, the major axis is under X, so that's the X side to side. Major axis horizontal. So if the center is 5, negative 2, this one will be 5 plus 3 would be 8, negative 2. 5 minus 3 would be 2, negative 2. Or again, I could just look at the graph. I have it right here. And then our co-vertices, this one would be 5, 0. This one would be 5, negative 4. And then our foci, we go 9 minus 4 is 5. Square root of 5 is our C, so we do plus 5, which is again about 2.3. So this is, we're adding it to the X coordinate, so it'll be 5 plus square root of 5, negative 2, and then it'll be 5 minus square root of 5, minus 2. Okay, and that's it. That's your graph. All right, and our last learning objective, solve applied problems involving ellipses. Many real-world situations can be represented by ellipses, including orbits of planets, satellites, moons, and comets, and shapes of boat keels, rudders, and some airplane wings. A medical device called a lithotripter uses elliptical reflectors to break up kidney stones by generating sound waves. Some buildings, called whispering chambers, are designed with elliptical dome so that a person whispering at one focus can easily be heard by someone standing at the other focus. This occurs because of acoustic properties of an ellipse. When the sound wave originates at one focus of the whispering chamber, the sound wave can be reflected off the elliptical dome and back to the other focus. So basically all the sound waves coming out from the person standing here hit the wall, right? It spreads out, and because the distance from any point on the ellipse, from focus 1 to a point on the ellipse to focus 2, is going to be the same distance. What happens is the sound wave coming out of the mouth, there's very little sound waves that are lost, that get spread out because they all get concentrated back at the other focus. So a person that's whispering at focus 1 can be heard like you were standing next to them at focus 2, which is actually a pretty interesting thing. So if you ever get a chance to go one of these, try it out. Have a friend of yours stand on the other side and whisper, and then see if they can hear you. Okay, example 7. A large room in an art gallery is a whispering chamber. Its dimensions are 46 wide by 96 feet long, as shown in figure 13. What is the standard form of the equation of the ellipse representing the outline of the room? Assume a horizontal ellipse and let the center of the room be 0, 0. Okay, so we're basically going to, let's see here, we're going to kind of think of it this way. Okay, so the center is going to be 0, 0. And then, now if this distance from here to here is 96 feet, then you can figure out that that vertex is going to be half of that. So 96 divided by 2 would be 48. 48, 0. This would be negative 48, 0. Okay. What is the standard equation of the ellipse representing the room? Hint, horizontal asymptote, let center room point 0, 0. So we know we're going to do x squared over a squared, y squared over b squared equals 1. All right, so this will be 48 squared plus y squared over, now b again would be the covertex, so if this is this distance is 46, so half of that would be 23. So 23 squared. Okay, so that's our standard form. If you want to go ahead and multiply those out, you can. You don't have to. So this is 2304. And then this one is 529. Okay, so that's A. Okay, B, if two visitors are standing at the foci of this room, can hear each other whisper, how far apart are the two visitors? So we want to figure out C. So we know C squared is B squared minus A squared. So we're going to do, oh, it's the other way around. A squared minus B squared. So it'll be 2304 minus 529, which equals 17, what is it, 1775. And then we're going to square root that. So that would be, and again, it'll be positive because it's a distance. So it will be about, punch that in our calculator. Where is my calculator? So 1775 square root, about 42.13 feet. So 42.13 feet. Now, how far apart are they going to be? So we want to know 2c, right? So 2c, so times that by 2, so that'd be 84.26 feet. Okay, so that's for B. Oh, round to the nearest foot, so 84 feet. Okay, 84 feet. All right, and that brings us to the end of the section. So again, practice, practice, practice. Make sure you go to the end of the section, do all the exercise or all the odds at least, and you know what to do from there. All right, have a great day. Talk to you next time.